Hi, I'm Bob Hughes of JD Squared. I'm standing in front of one of our traveling head rotary cutters. And the purpose of this video is to show you why we made the decision to go away from a machine that moves the tubing to a machine that moves the head instead, referring to a traveling head machine. Let me go ahead and stop this machine here for a minute. We're going to stop it right there. Okie doke. All right. Anyway, traveling head machine is a machine that the torch, everything like that, itself moves up and down the track. It's got huge advantages over what I refer to as a Pinocchio machine. And a Pinocchio machine is a machine that instead of the head moving, the torch is stationary and the tubing itself moves up and down the machine. It turned out that this is the fifth machine that we built before we finally felt that we had a winner. One that I myself would want to own, that we could sell to you and not get yelled at trade shows. I love everything about this machine, but our first three machines were Pinocchio style machines, kept getting better and better. By the third one, we had the best one in the world. Great machine, and I didn't like anything about that machine. Once you ran it in real life, the shortcomings were just in your face. So we literally threw away all that investment and started over and created a traveling head machine, first prototype 4, and then finally the final version of the machine, this one right here. It's got so many advantages to a rotary, to a Pinocchio machine, that what I did is I went into our prototype graveyard and I shot a short video segment at our rotary machine to show you some of the problems and describe to you the problems that we had with it. But anyway, this is a traveling head, so let's shoot over and take a look at that segment right now. Okay, I'm now standing in our prototype machine graveyard. This is where we store all the machines that didn't make the cut. We've got a wood router right there. We've got our fourth rotary plasma cutter. That was a traveling head machine right over there. Anyway, you're looking at the third and final version of our Pinocchio style machine. And I refer to Pinocchio machines as the ones that feed the tubing in and out of the front of the nose of the machine, kind of like Pinocchio's nose growing. There's no covers on this machine because, like I mentioned, this is a decommissioned machine. Anyway, what we did is the first three machines we made were this style machine, and we set out to design the best machine in the world for anywhere near the price, and we accomplished that with this machine. It was a very, very good machine until we started using it. And then we started learning the shortcomings of these machines very, very fast. So let's go through them. First one has to do with the fact that we're running servos and not stepper motors. Stepper motors are fine for hobby machines, you know. But in reality, when have you ever seen a servo or a stepper motor on something like a laser or a high-def plasma or any quality machine? You're not going to see servos on them. They're the low-dollar solution. We're not shooting for the low-dollar solution. We're shooting for a performance solution. Therefore, we use servos on all of our machines. Now, servos like to be tuned for a particular mass. They want to know how much weight we're moving so that you could ideally tune them for optimal performance. You can't do that on a machine like this. And the reason is very simple, and I can explain it. I can show it to you, illustrate it better than I could explain to you. Let's just take this piece of tubing right here. 4 foot long, 1.5 inches, feels like it's 11 gauge, something like that. So anyway, I don't know, what, it weighs 8 or 9 pounds, right? So you're moving this mass up and down, plus obviously the chuck on the back side, the carriage. You're moving it up or down, and your servos are tuned for a particular weight. So let's just say they're tuned for this being 12, 14 feet long, right? So you're going to get optimal performance. You're going to get beautiful cuts similar to our flat beds, and you're going to be a happy camper. Now, you're going to come along and you're going to load up a piece of 20-foot tubing, 3-inch OD, 1/4-inch wall. Extremely heavy piece of tubing, right? Probably 30, 40 times heavier than this right here. Well, your servo tuning just is gone. You're not tuned for that kind of mass. So the cut quality won't be as good or what you expect. You're just basically making compromises. So the only way to accomplish that on this machine was to pick the middle ground. Go somewhere between very light and very heavy, tune the motors for that, and then anywhere on either extreme of that, you're just going to have to live with a subpar quality cut. We don't have to do that on the traveling head machines because the head is always the same weight. We're moving those axes the same. The only thing we're changing is the speed of the rotation axis, which we just put in big motors to make sure that we're going to handle that kind of acceleration even if you put something big in it. So those motors are overkill for little tubing, but they work the entire range. Whereas moving the head and everything like that, you're seriously going to want to have the servos tuned for that weight. So that was a problem right there. The other problem you run into is a physics issue. So if we take that 20-foot long piece of tubing, the 3-inch, quarter-inch wall, very heavy piece of tubing, could easily weigh a couple hundred pounds, right? And let's just say you got a 20-foot piece of tubing you're going to load up. You're going to cut an 18-foot piece out of that tubing, which means you're going to have 18 plus feet, about 18 feet 4 inches, hanging out the front of this machine. Now, if you support it on rollers, you've got an issue. How are you going to do that? Somebody's going to have to go down there and pick it up and put it on the rollers, or you're going to put a series of rollers down it, which means you're limited to round tubing at that point because you can't roll square tubing in a roller. So that's a problem right there. But the big problem has to do with the lever effect. If you're out 18 feet, you've created a lever, and it's pushing down right here. And you can kind of see the cable carrier moving in the back of the frame right there. I'm actually trying to lift the carriage off the machine. But the bottom line is you've created a lever with the nose of the machine being the fulcrum point. So let's just take our example of our 200-pound piece of metal. You could easily, you won't exactly have a 9-to-1 ratio right there because the weight's spread out over the entire length of the tube, but you could see where it'd be very easy. Most likely, you could have somewhere maybe between 1,000 and 1,200 pounds of down force pushing down at your nose. Well, these systems can't handle that kind of weight. I mean, just think about it. I mean, that's half a ton, you know? So traveling balls won't handle the weight. If you have a roller system that moves in, it won't handle the weight because you're going to have some kind of gear mechanism to move it in and out. You're going to blow the gears off. So we found out very quickly that that was a huge shortcoming, just the physics alone of what we were able to cut. Now, let's talk about the safety issues of these machines, and they became very substantial. Like I said, if you're feeding the tubing out 20 feet, somebody, a lot of people are doing this, are putting somebody out there with a pair of gloves and they're holding it up while it cuts. Now that would have to be done, especially if you're trying to do square tubing. Now the machines that are out there currently can handle square, some rectangle, and some round tubing. I haven't seen any of them that'll handle channel, L beam or anything like that, and actually do it elegantly. I don't mean just, oh yeah, we're getting it done. I mean actually do it like they were made to do it. So you've got that problem there. So if somebody was out there trying to hold a piece of square tubing or something turning, you can see the problem right there. All right, so that is the problem itself. The other big problem, and you seriously need to pay attention to this if you have one of these machines or you're thinking about purchasing one, is OSHA. OSHA will nail you to the wall. If they walk in and see one of those machines there, and it has the capability of cutting 20 feet long, and they expect you to have 20 foot of guardrail in front of this machine to protect somebody, because if you've cut a cope on this end right here, a notch, you've effectively created a very good spear. You could just drive right into somebody's abdomen. It's such a severe hazard that we very quickly learned that we had to slow down the speed of the tubing through the machine to 300 inches a minute. That's almost 1/4 the speed that we could run the traveling head machine, drastically screwing up production and everything. It was just bad, but it was the only way to you maybe give somebody enough time that if the thing hit them in the abdomen, maybe they can get out of the way quick enough. At the speeds that the traveling head machine runs, that isn't going to happen. It's in them, you know, if it contacts them. So being a manufacturer and not wanting to get sued, and more importantly, not wanting to see anybody injured in the field with our machines, we decided that we are never going to build a moving tube Pinocchio style machine and produce it for that reason, you know. Now, so keep in mind those safety issues right there. The other issue turned up very quickly was water injection. Water injection is a huge help on these machines to try to maintain a good cut quality, because what you've done is you've shot a plasma beam right through the top of your tubing. Well, it's contacting the other side of the tubing, and that's heating up the metal very quickly on the other side. So as your tubing rotates around, by the time it gets up to 180 degrees, you are no longer cutting relatively cool tubing. you're cutting extremely hot metal at that point. The hotter the metal, the more slag, the worse the cut is, but there's really no way around it, right? You shot a plasma through it. Well, one way to greatly minimize that effect is to inject water through the tubing, and that helps tremendously, especially if you're doing aluminum. So our traveling head machines are all designed with water injection in mind right from minute one. I mean, we just knew it was that important. These machines here, let's just say you're going to do water injection, effectively, if you want to handle long pieces of tubing, you're going to have some kind of trough all the way out in front of this machine to handle the water flowing back out of your tubing. Now, don't get me wrong, these trough systems will not catch all this water. I've mentioned before that rotary cutting machines are notoriously dirty, and that's because you're shooting on a round piece of metal, or even if you're doing square, you're rolling up on the corners. You've just created a million ways for these sparks to fly, but that's a problem that you'll have to handle in your facility. But from a water point of view, we're going to want to catch as much of the water flowing down as we can. Therefore, we're going to use a trough. Okay, we've already mentioned the versatility. Traveling head machine has no problem with different shapes. And I'll give you an example of a shape that for sure will never work on one of these kind of machines. And that's a flagpole. So we had a gentleman ask us, he's making 8-sided flagpoles that are tapered. And he wants to know, I want to cut these things. I want to cut all the holes in it up and down. Can a machine do that? Our traveling head machine has got no problem doing that because we run a roller system. So what we're going to do is we're going to create the master holders that would hold the big end of the flat of the flagpole. They're rolling in rollers. Then the same diameter holders at the other end, but it's got a smaller opening, so the tapered end is into that. And we have no issue holding or rotating that kind of shape. Same thing goes for weldments. You could weld a weird weldment on your machine and go, okay, I want to weld it first, then I want to process all my holes so they're the right length apart and everything. You could do that on our traveling head machine, and we don't even care what shape it is. As long as it will fit into the envelope of the machine, we can make holders to hold it. Clearly, you can't do that on a Pinocchio machine, All right, so let's talk about the only two good things about these machines. One of them is from a manufacturer point of view, and that has to do with how easy and cheap they are to build. I mean, if you build one that you're just using a piece of tubing as the frame rail, these things are cake to manufacture. And as a consequence, from the manufacturer point of view, they make a lot of profit. However, you're not really building a good machine. You're just building a machine to maximize profits. We clearly are interested in taking your money out of your pocket and you voluntarily putting it in ours. But it isn't all about the almighty dollar. We want to be able to go to a trade show and you not come into our booth and very upset that you paid good money for a machine and it was clearly inadequate for the job from day one. We don't want that happening. So anyway, that's the only good thing there is for the manufacturer. There is one application, however, where these machines shine pretty well. And to give you an example of one, now they all have to do with utilizing very short work pieces. You're cutting small pieces off. And a good example would be a company who's building, for instance, ATV control arms. Relatively short pieces, right? They want to load up a 20-foot piece of tubing and wham, 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 cut them, drop them into a bin, and away they go. This machine works fairly good for that because we could tune the servo for half of the weight of that material. So we're getting a pretty darn good cut throughout the length of the material because we're not going to anything giant. And control arms are small, 3/4, 1 inch diameter, something like that. And it would be easy to do water injection because you're dealing with a short little section here. So you don't have to worry about 20 foot of tray out there. And the other thing is that if you could easily make an injection system into a bin. Now, to get around the OSHA problem in that situation is fairly simple. You're going to put a steel barrier in front of the nose to limit how far the tubing can come out. And I don't mean a steel barrier that you can flip a lever and drop out of the way and do a long piece. That doesn't cut it. If you don't want to get fined by OSHA, you have to have a physical barrier that cannot be easily defeated, in which case you got a fairly safe machine. Tubing can't feed out, can't hurt anybody. You've got your water collection system, and you can drop into a bin. These machines are very good for that application. Now, the funny thing is, I have never thought of another application other than dealing with short little work pieces that these machines are even suitable for in the remotest way. So anyway, thinking of that problem right there, we have created the workaround on our traveling head machines. And what we do is on the traveling head machine, we're motorizing the chuck, so it itself goes up and down the frame of the traveling head. So you have a traveling head moving and a chuck moving. Now you could have your cake and kind of eat it too, because you could do both, you know. It just drives the cost up a little bit because you've now added another axis to the machine. But it can be done. It can be done safely, and it can be done in a 20-something foot envelope, whereas these machines are always going to be longer than the workpiece because they just have to be, you know. All right, so anyway, that's the general overview of why Pinocchio machines are not our particularly favorite type of rotary cutter. So there you go. Okay, we're back at the machine, and before I explain how a traveling head machine solves those problems that I just mentioned, let me tell you a little bit about what you're looking at. You're looking at our standard machine, which has a 12-foot long frame. Now the carriage itself is about 18 inches long, and you're going to lose that distance in your cut travel. So effectively a standard machine can cut 10.5 feet long. And the same thing with the tube frame, they're 12 foot also. Now we do offer extensions in 6 foot and 12 foot. So by buying an extension, this particular machine could be lengthened out to 24 feet. Take away the 18 feet for the carriage, you got a cut length of about 22.5 feet, which is about what most people need. We can go longer than that. So we also make, this particular machine here is a 6-inch pipe machine, so it'll cut up to about 6 5/8, just around 7 inch in that area. But we also can build them in 12, 18, 24 inches, 30 foot long, 40 foot long. So the basic configuration of what you're looking for is how we're going to build all of our machines. So I just wanted to let you know that that's what you're looking at right here. Okay, let's look now at the problem of servo tuning. And what it is you are moving the mass of the workpiece on a Pinocchio machine, which we couldn't predict the weight because we don't know what the user is cutting. This machine eliminated that problem because we've moved to a traveling head, and we do know the weight of this head. So we could precisely adjust the servos up and down for optimal cutting speed because we're not varying the load that they're seeing. Solve that problem completely. Now another advantage of a traveling head is we can put a tilt head system on it, which we have on this machine. It's tilt head for doing chamfering. Could not do that on a Pinocchio machine. Some other advantages are, for instance, we could remove the head, and all of our machines come with a router attachment right here. So you can literally put a router on it. We had one artist, he wanted to route PVC with really cool shapes, and he was going to backlight it and make this really cool thing. And he saw this machine, and he was fascinated by it because of the router. So he could load PVC. You could actually load wood in this machine and cut columns, wood columns or stuff like that with it. So a little more versatility for that. You may or may not be doing that, but I'm just trying to give you an overview of what the machine is capable of doing. Okay, so now let's talk about the second feature, which is the safety issue. Since we're not moving the workpiece, we don't have to worry about getting gorged by a sharp piece of metal that you put a notch on the end, like that one right there. The workpiece is entirely in the envelope of the machine. So that solved your safety issues right there. Now, another thing that became much easier to do on this machine was add a water injection system. Now, this machine is equipped with the optional stainless steel reservoir, pump, hose, and everything like that for a water injection system. But all of our machines come with a water tray. The full length of the cut has a water tray. Whether you buy the injection system or not, this helps catch debris also instead of trying to get all over the floor. I did mention that these machines are notoriously dirty. I'm not kidding. You're going to have to keep wiping them down, you know, occasionally. It just, I mean, you're spraying round tubing. The stuff's going everywhere. But at least this helps a little bit, but mainly it's there for the water injection system. So that problem went away. Now, water injection systems all have removable plates right here, and they just slide in their slots. They're easy to take out. And we did that so that you could forklift load heavy material in this machine without those being in the way. Then you just simply replace them. All right, so now let's talk about different materials. First, I'll talk about material that doesn't rotate. Here we got a rotary cutter, and I'm going to tell you how to cut things that don't rotate. Seems kind of weird, but it's actually extremely useful. And what we did, and this was another reason why we CNC and keyed the tube frame itself. And the reason is so that we could build a bunch of different kind of fixtures to hold different sizes and styles of work pieces. And one of them happens to be flat. And when I say flat, I'm talking a flat strip, a channel, an I-beam, a piece of square rectangular tubing that you don't want to rotate, or maybe bigger than we could handle inside our 6 5/8 envelope. Remember, this machine will go up to 6 5/8 round. This particular one will go up to about 5-inch square. You know, anything within a 5-inch square, you're good to go. If it's bigger than that, you can't do it. But you can handle flats. And that's because the torch will transverse in and out about 17 plus inches. So anything in that envelope you could cut. So a particular gentleman wanted to cut 12-inch channel. We would build little brackets that bolt onto here that have a back fence. He could forklift load his 12-inch channel in here, bump it against the brackets, and now start cutting his holes and know that they're precisely aligned with each other and the correct distance apart. Easy peasy on this particular machine. Same thing with I-beam, stuff like that. So keep in mind that the machine is very versatile. Doesn't have to just rotate. You just got to keep it within the envelope of the length of your machine and 17 inches, and you can cut it. Okay, so we've done that. Now let's go ahead and talk about rotating work pieces. And there's different shapes: round, square, rectangular, octagon, all kinds of shapes, you know. Now what we have in this machine here is the one that is most popular. And it's going to be for people who are doing round tubing or pipe under 3 inches OD. We're not talking 3-inch pipe. So you go 2.5-inch pipe, but you couldn't go 3-inch pipe. You know, so that's what this one does. Now this system here is engineered. It's pneumatically powered, and the pressure is adjustable on that. So if you're handling aluminum, whatever, but it will conform from 1/2 inch up to 3-inch, and it is self-conforming as you're rolling. So if your pipe is oblong or your tubing's oblong or wrong shape or whatever, the roller system will float with that. So you have no problems maintaining that. Now, on a tube stabilizer, we can do square tubing or rectangular tubing up to that 3-inch envelope. And it's a separate adapter that bolts in. It's easy to change out. This whole system comes off the machine in about 20 seconds. It's 2 bolts, disconnect the wires with quick disconnects and the hoses, and she comes off the machine. But we can do that, but we feel we have better ways of handling square and rectangle that is more predictable, and it just provides a better experience overall. But anyway, let's just say you had this on the machine and you were cutting 20-foot long tubing. You're going to run this to one end of the machine. Well, what's going to happen is your tubing is going to sag in the middle. Now this could be for square tubing too, but in this instance we're talking about round tubing. So what we developed was this lifter system here that can be adjustable by pressure to how much force it's putting out, and also where it stops. So we could simply adjust this by moving this whole system in and out to where she would come up to a certain position and lock in, and you would just adjust her regulator to full pressure, max force. You couldn't push that roller down to save your life. Now, that works great for round tubing. But one of the advantages of our lifter system is if you're doing non-round tubing. Let's say you're doing square. So for instance, right here in the machine is a piece of 4-inch square tubing, and as I roll it, notice how the corners are going up and down, right? Well, it turns out with the simple addition of an adjustable air regulator, we could adjust the pressure so that our lifter system conforms as you're rolling. Because the idea of the whole system is to support the tubing. So to put that in perspective, if you had a 20-foot piece of tubing and it was sagging, you would adjust the air pressure to be the equivalent of you taking your hands and just lifting the tubing up. Whatever force that is, that's what you're going to do. You're not going to make this thing perfectly level. You're just trying to get rid of excessive sag. And you can imagine if you had a piece of 1-inch square tubing that, you know, or 1-inch round, 20 foot long, you've got a sag in that boy. So this is how we try to accommodate that right there with this system. Now, let's go ahead. We'll take this out of the machine. I'm not going to do it, but you know what I'm talking about. This is no longer in the machine. We're free, and we're going to cut items larger than the 3-inch right there. Now, specifically, let's start off with this system right here. Now, this system here has rollers, and it has plates that catch the rollers. And what the idea is that we have these adapter rings right here that will adapt to your different shapes. Now, on these adapter rings, we can bolt adapter plates onto the ring that will allow us to go to different shapes of material. So, for instance, this ring here has been made for 4-inch square tubing. But you can see these extra holes right here on two sides. We have laser cut plates that will bolt into those and easily allow you, and that's why there's multiple holes out there, because a single plate could accommodate different sizes. So we're able, with that simple fixture right there and adapter plates, to handle tubing from 3/4 up to 4-inch without having to buy any more attachments. You just move the adapter plates to different positions and away you go. Now that's incredibly versatile, because this exact same ring mechanism, if you didn't want to do square rectangular tubing, you could put 4-inch channel in it. You could put 4-inch I-beam in it or something like that because of the adapters. So it becomes very, very versatile. Now, if we were doing round pipe or anything bigger than 3 inches and above, then we're not going to use this system. We're going to use the roller system, where the rollers are above the plates, and it allows the material itself to roll on the rollers, you know. Now, here's something cool about this machine. The frame has been CNC machined. So when we start bolting adapter plates in it, you don't have to worry about individually using like scissors and everything. You know, a lot of roller machines have scissor adjustments on it. You don't have to worry about that with our machines. You put the plates on it, you put your tubing on it, you're good to go. The power head is where the vertical adjustment is made. This particular power head could adjust up or down just about 4 inches or so. So we would adjust the power head down or up to match the tubing, you know. Now, here's something else really, really cool about our machines, is we don't have to drive the material itself by the chuck. We developed a system, and that's the subject of another video, to where we load up a drive shaft in this system right here. And we're basically using a drive shaft with an adapter ring to drive that ring, and that turns the material. And that really solved a lot of problems. A lot of them have to do with oblong tubing, because you want the least number of supports that you could put on the tube to support it. So the drive shaft, if you have a wobbling effect, or you have a work piece that's is obviously not out of round, oblong or something, the drive shaft can conform to it, and it's very easy to load up your workpiece and then just adjust the head up or down. So that was another huge advantage of the machine right there. But let me give you one other scenario where this machine would work beautifully, and a Pinocchio machine, you could do it to save your life. And that would be an application that a gentleman came up to me at a trade show. He's doing 8-sided flagpoles, tapered flagpoles, 30, 40 feet long, or whatever they were, you know. And he goes, I want to cut this flagpole. Can this machine do it? And the answer is absolutely it could do it. And the reason is because of these adapter rings. So we would make him a set of rings for his material, adapter rings, that will allow him to chuck the taper in. So one of these is going to be a smaller cutout than the other side because of the taper. We're going to put the small cutout on this end of the machine. We're going to drive the whole system through the drive shaft. This way we can inject water into his tapered flagpole, and the water will run down the taper, allowing us to apply some kind of cooling effect to his flagpole, you know. So that was another thing that this style machine will allow you to do that a Pinocchio machine wouldn't. So anyway, those are the main advantages. Now, one advantage now they are obviously, the two advantages of the Pinocchio machine, other than being easy to manufacture, was short piece cutoffs. I'll talk about that. Clearly, this is not a machine that's as easy to manufacture as a Pinocchio machine. In fact, it takes us about 3 times longer man hours to manufacture this one. But once again, I don't want you yelling at me at a trade show because your machine won't do the job. We'll put the time in for you. Anyway, let's talk about the other advantage to a Pinocchio machine and how we figured out how to solve that. And that has to do with working with small material. You're doing that ATV control arms. You want to cut these small pieces off and drop them in a bend. With this machine here, you're looking at the option of putting in a bunch of catchers and basically cutting the material and catching it in these catchers. Well, sure, that'll work. You could come along and you could pick them all up. You could do that. In a high production environment, it's probably not a good idea to do that, but you could do it. Now our chucks here, you're able to place and run through the chuck 1.5 inch tubing. We never recommend that. The reason we don't is water injection. You can't inject water if your tubing's hanging out the back side. At least you can't do it easily. So we always want the tubing to be in front of the chuck so that we can catch the overflow, you know. So what we're going to do, we haven't done it yet. If somebody wants to order it, we've already know exactly how to build it. By the time you're watching this video, if you're watching a year from now, there'll be other videos showing the system. I'm getting ready to describe to you. But what it is, instead of having a fixed power head right here, we're going to put another power head that itself travels up and down the frame. So you'll actually have a machine that you could have a traveling power head and a traveling cutting head on the same machine. Now, in that instance where you want to cut all these little short parts and drop them a bin, what would happen is the traveling power head would be feeding the tubing through. Now, since we're dealing with a relatively known size tubing, then we can adjust the power head. Remember, because we care about how much mass we're moving up and down the frame, we can adjust the servos for that particular application and have very high quality cuts. So what we would do is run the power head to the back of the machine, run the cutting head all the way to the front of the machine here. We would set up our parts catcher over here, our physical stop so that OSHA doesn't get after you, so that the tubing can only go so far. And basically we would emulate the Pinocchio machine using this. That could be done. It's not even that hard to do. It is more money, however, because essentially we are adding another axis and a whole system to the machine. But that's how our workaround would be, or if you're doing short pieces where you have a safe machine that that you're able to produce without, you know, having OSHA climb down your back, you know. Anyway, that's all I can really think of talking about the machine right here. If you've got any other questions or material requirements that you're interested in, or you just want a larger machine than this, please don't hesitate to email or call us. And as usual, we're here for you. Happy cutting. Thank you for watching. Goodbye.